In this ACT review video, we are going to take a look at the special right triangles with trig functions. In the previous video, we discussed the special relationship between the sides of the 45-45-90 triangle and the 30-60-90 triangle. So we're going to use those triangles in this video to find the exact values for our three main trig functions. So here we're going to start with sine, and you can see I have three examples on the left. Find the exact value of the sine of 60 degrees, the sine of 30 degrees, and the sine of 45 degrees. So to answer these, to give these values, we need those two special right triangles that we discussed in the previous video. So the first question asks for the sine of 60 degrees. So let's just draw our 30, 60, 90 triangle. Let's see, 30, 60, 90 with the sides. Remember we said we need to have this one memorized because these three angles are very important and they pop up all the time. And we're going to label this with a right angle right here, 60 at the bottom, 30 at the top, 1, 2, square root of 3. Now, we're also going to use our definitions of our trig functions. So remember, we discussed maybe using SOHCAHTOA to help us remember the definitions. So we're looking for the sine of 60, and remember sine is the opposite side over the hypotenuse. So we need to go to our triangle, we need to find the 60-degree angle right here, and we need to go opposite of it, which would be the square root of 3 over the hypotenuse, which is 2. So we can say that the exact value for the sine of 60 degrees is square root of 3 over 2. And you probably know that this is something that just pops up all the time. 60 degrees is actually an angle that's in quadrant 1 if we were to draw that on a coordinate plane. And that's something we're going to look at in a video to come. Let's go ahead and do sine of 30 degrees. Okay, and 30 degrees is right here. Definition of sine is opposite over the hypotenuse. So we go opposite of 30 degrees, and that's 1. And the hypotenuse is still 2. So the sine of 30 is 1/2. We're leaving these as fractions, and we're leaving these with rational pieces because we want to find exact values. All right, now for the sine of 45 degrees, we need to draw our 45-45-90 triangle. So I'll draw that over here. Just a little sketch, good enough. And I just don't have room in there to put the 45, so sometimes you'll see me just mark those legs congruent. Remember, when those legs are congruent, we know that the angles have to be congruent, so this is definitely a 45-45-90. 1, 1, hypotenuse, square root of 2. And you can choose either one of these 45-degree angles. I'll just choose this bottom one right here. Sine is opposite, which is 1 over the hypotenuse, which is square root of 2. Notice I wrote it over here because I knew what was coming. 1 over the square root of 2. You guys know we can't leave that radical in the denominator, so we actually have to do a little bit more work on this one and rationalize it. So let's go ahead, multiply by square root of 2 over the square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is just 2. So the sine of 45 is the square root of 2 over 2. Okay, now some of you may have these values memorized for these special trig function values, but you can always just memorize these two triangles and then use your definitions. Let's do cosine. So we're going to do cosine of 60, cosine of 30, and then the cosine of 45. Let's go ahead and draw our 30, 60, 90 triangle again. And it seems a bit redundant since we drew it on the other slide, but if you draw it every time you use it, you will definitely have it memorized by ACT time. So 60, 30, this is 1, 2, square root of 3. And since I know we're going to do 45 and 45, I'm going to go ahead and draw 45, 45 over here also. These are not necessarily to scale, guys. These are just sketches, just so I can match up my sides. 1, 1, square root of 2. And that's our 45, 45, 90. All right, so cosine, If we use SOHCAHTOA, remember cosine is adjacent over hypotenuse, so that's the definition we're going to use for all of these. And looking at the 30, 60, 90, the cosine is 60. Here's 60 degrees. Adjacent or next to 60 degrees is 1. And the hypotenuse is 2. So the cosine of 60 is 1/2. Cosine of 30, here's 30 degrees. And now next to or adjacent to 30 is the square root of 3. And the hypotenuse is 2. So it's square root of 3 over 2. And then lastly, cosine of 45. Let's go over here to the 45, 45, 90. Adjacent to either one of the 45 degrees that you choose. It doesn't matter, but we'll choose this one. Adjacent to 45 is 1 over the hypotenuse is square root of 2. And just like the sine of 45, we're going to have to rationalize the denominator on this one as well. So let's multiply by square root of 2 over the square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is just 2. So cosine of 45 is square root of 2 over 2. So you probably noticed that these are kind of the opposites, at least the 30 and the 60 of sine. The sine of 60 was square root of 3 over 2, and the sine of 30 was 1/2. And then cosine of 45 and the sine of 45 are both square root of 2 over 2. So that's kind of neat, and you might end up having it all memorized when it's said and done anyway. Lastly, let's do tangent. And we know SOHCAHTOA, tangent is opposite. Tangent of an angle is opposite over adjacent. Tangent theta is opposite over adjacent. So, going to draw those two special triangles again, 30, 60, 90. The more you draw them, the more you're going to have them memorized. And 45, 45, 90, I'm going to go ahead and draw another triangle since we're going to do both of these. And this is going to be not the best triangles, but again, they're just sketches, so we have these sides so we can fit them into these definitions. 1, 2, and square root of 3. And 1, 1, square root of 2. Okay, so 30, 60, 90. Here's 60 degrees with respect to 60 degrees. That just means we're looking at the 60-degree angle. Tangent is opposite, square root of 3, over adjacent 1, so you may just write that as the square root of 3. Tangent of 30 degrees. Tangent of 30 degrees, here's 30 degrees, opposite of 30 is 1, adjacent to 30 is square root of 3. Can't leave that radical in the denominator, so we need to rationalize it. We're going to multiply this by the square root of 3 over the square root of 3. 1 times square root of 3 is square root of 3 over square root of 3 times square root of 3 is just 3. So the tangent of 30 is square root of 3 over 3. And lastly, the tangent of 45, you can choose either one of these 45-degree angles. I'm choosing this one right here. Opposite of 45 is 1. Adjacent to 45 is 1. 1 over 1 is 1. So you need to practice finding your function values for the 30, 60, 90 and the 45, 45, 90, because in a upcoming video we'll be doing the same thing except using some bigger angles, but it's all going to come back to these two special right triangles.